So we have the 2025 VCE Math Exam, the exam 1 for math methods. Let's have a go. I'll also be skipping all the probability questions. Easy derivative question, use the product rule. So 2x cos of x plus x squared times negative sine of x, which simplifies to equal 2x cos of x minus squared sine x. And now I'm going to use a thinner, let me use a thinner one. Okay, cool. Find the gradient of the tangent at x equals 8, so that means we should derive this. So f dash of x equals 3 bracket x plus 1 to the negative half. At x equals 8, so we substitute 8. 3 over, okay. 3 over 9, okay. 3 over root 9, which equals 1. Let g of x be a function, find g of x. X. Okay, so we've got to first derive this, integrate this. 1 over g of 1 equals 0. Okay, let's make sure. So ln of 5 divided by 2 equals c. So okay. And another thing we can do in question 2 is, as we see this is half, this is also half. So I can just combine it into 1 half and say ln 2x plus 3 minus ln 5. And what do we know? That if there's the same base, we can say 1 over 2 ln 2x plus 3 divided by 5. Right here in question 3, we have the full range. So if we have 2 times -1 plus 1, that equals -1. And if you have 2 times +1 plus 1, that equals 3. So the range is around -1, 3. F of x equals 0. Okay. -1 over 2. So let's just say cos theta equals -1 over 2. So for cos of theta to equal -half, that means we need a solution like this and this. So theta equals 2 pi over 3, 4 pi over 3, 8 pi over 3, and 10 pi over 3. So therefore x equals 2 pi over 6, 4 pi over 6, 8 pi over 6, and 10 pi over 6, which can be further simplified to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Sketch the graph for pi on 2 to 3 pi on 2. Pi on 2 is -1, which is here. And then 3 pi on 2. Very bad graph. Endpoints with their coordinates. So pi on 2, -1. 3 pi on 2, -1.
You can use lots of methods to find the answer. Okay. A minus 7, A minus 1 equals 0. So e to the x equals 7 and 1. So x equals ln 1 and ln 7. So x equals 0 and ln 7. Let g of x equals e to the x 1. Find the largest value of a such that g is... Okay, cool. So, if we imagine a graph, there are two intercepts at these points. So it's like, okay, cool. G dash of x equals 2 e to the 2x minus 8 e to the x. One stationary point, and it's a minimum. So g dash of x equals 0. So therefore 2 e to the 2x equals 8 to the 8x. So oops, okay. Find the largest value of a. Oh, okay. I'm gonna skip probability, bro. Verify that x equals 5 is a solution. Okay, so in this question, I don't think you have to factorize and show that it equals 0 with null factorable, because that's what you have to do in here. So we're gonna do it here. So verify that x equals 5 is a solution. You can just say 5 to the power 3 minus 5 squared minus 16 times 5 minus 20 equals 125 minus 25 minus 80 minus 20 equals 0. Also here you want to just quickly write f of 5 as well. Express f of x in the form. Let's use synthetic division. So 1, -1, -16, -20, 5. 1, 4, 4, 20, 0. So we have x minus 5 bracket. Okay. So after we use synthetic division, then we go x minus 5 x squared plus 4x plus 4. And then this, as you can see, is a nice little perfect square. So it's x plus 2, but they want it like this. So we can say, finally, f of x equals x plus 2 squared bracket x minus 5.
Complete the coordinate pairs of all axial intercepts. So this is a negative. Is this coming from here? Okay. It's going to be -2 and 5. And this one is going to be the y-intercept, which is -20. This is a very 3 marks. It's only 1 mark. Okay, good. State the coordinates of the stationary point of inflection. So f of x is being multiplied by g of x. So therefore we have a function of this being multiplied again by x plus 2. So we have x plus 2 squared x minus 5 being multiplied by x plus 2 again. As you can see, this will be to the power of 3 because of that. So therefore the coordinate would be at -2. And if I substitute -2, so let's write this out first. So x plus 2 cubed bracket x minus 5. So no one else, only 1 mark because it's going to be to the power of 3. And if I make x equal -2, then this will equal 0. So write down the values of x for which it is greater than 0. Okay. So let's imagine we multiply this by x plus 2, and it has to be greater than 0. So as we know, this one is a chordic, which means there's going to be 2 parts where it's going to be greater than 0. We're going to find those 2 parts. So we know the x-intercepts are at 5 and -2. So this part is all positive, and this part becomes positive. So I can just write x is an element of -infinity to -2 union 5 to infinity. Oh, thanks. All right. I'm going to ignore this row just because. Okay, cool. Consider these functions. If w equals -3, find 4 solutions. So let's quickly substitute -3. So -3 to the power of 2 is 9. And x minus -3 is also known as x plus 3 squared. So let's find the 4 solutions. We have 9 equals x plus 3 squared bracket x minus 1 squared. And we have to find 4 solutions to this. Okay, so we can expand and get x squared plus 6x plus 9 bracket x squared minus 2x plus 1. And then expand again and get x to the power of 4 plus 4x cubed minus 2x squared minus 12x plus 9. And we can kind of cancel out that 9 from both sides. And then we get a nice 0 equals x to the power of 4 plus 4x3 minus 2x squared minus 12x. And then also factor out that x, which means one of the solutions is x equals 0. So if I factor out that x, I get 0 equals x to the power of 3 plus 4x squared minus 2x minus 12. So yes, I know that it has to be something to do with the number 2. So I want to trial -2, also because this last part is negative. So if I do that, let's use synthetic division again. 1, 2. Okay, perfect. So that leaves me with another answer of x equals -2. So then I get a function of 0 equals x squared plus 2x minus 6. You got to use the quadratic formula and you'll get your two solutions of x equals, so I'm going to just write use quad formula. You guys can do that by yourselves. Negative root 7 minus 1 and x equals positive root 7 minus 1. Okay. Find the case where, find in terms of w the coordinates of the minimum point of the graph of this. And w is greater than 0. So that means this right here is a parabola. And what do we know about parabolas? That if we have an intercept, the turning point is usually right in the middle. So they're saying essentially if w is greater than 0, there is going to be a 1 here for the intercept, and the next intercept is at w. So the the minimum point is right in the middle. You can use differentiation as well, but let's go with this method. It's nice. So the middle of that coordinate is right here. So I'm just going to write w plus 1 over 2. I say f of w plus 1 over 2, that equals w plus 1 over 2 minus 2, coordinate, oh bro, I'm actually dumb, okay, w plus 1 over 2 minus w. So let's simplify that if I can. W plus 1 minus 4 is being multiplied by w plus 1 minus 2w over 2, which equals w minus 3 over 2 times 1 minus w over 2, which equals w minus 4 bracket 1 minus w over 4. So finally substituting that point, I can get a simple answer of a simplified answer of negative w minus 1 squared over 4. If you expanded it, I think it should be fine. Like, they're not asking for a specific. So now we got this final question. Hence or otherwise find the positive values for w. So first of all, I'm going to write a note. W has to be greater than 0. Also, another thing to note was that because of this, x cannot equal 1. Find the positive values for w for which f of x equals g of x. So if f of x equals g of x, that basically means that w squared over x minus 1 squared equals x minus w squared. And then rearranging it, we can get w squared equals x minus 1 squared bracket x minus w squared. So the cool thing we notice about this equation is that it relates back to here, x minus 1, x minus w. So it's the same form, but now it's been squared. So we're going to square root both sides. So we get plus minus w equals x minus 1 bracket x minus w. And again, because this is hence or otherwise, that means we want to be learning from this equation or from the information we've just learned. So the y coordinate of the minimum point is right here. So we're going to get plus minus w to equal that minimum point. Squared divided by 4. So if we use the positive branch and solve, I'll show you what happens. So once we rearrange, 4w equals negative w minus 1 squared. And then, so once you expand everything, you get w squared plus 2w plus 1 equaling 0, which means we get w plus 1 squared equals 0, which means w will equal negative 1. And we know w has to be greater than 0. So let's use the negative branch. So we're going to use negative w. And then once we expand and move everything on each side, we're going to get w squared plus 2w plus 1 equaling 0. So here we're going to use the quadratic formula. I won't show it. But then we get a final answer of w equals 3 plus 2 root 3 and 3 minus 2 root 2. And we'll also double check our answers on decimals. So we got w equals 3 minus 2 root 2, which is 1715. And as you can see, there's exactly 3 solutions. 1, 2, 3, because this is tangent. And then our second solution is 5.828 to 3 decimals. And here again, this is supposed to be tangent. So 1, 2, and then 3 solutions there.